Welcome, my dear aspirants, towards learning some aspects under solid state. As in the previous videos, we studied or we discussed some aspects regarding crystalline solids, amorphous solids, crystalline solids further classified into molecular solids, ionic solids, covalent solids, metallic solids based on the forces operating among the particles. After that, space lattices are there. Space lattice is only indication of or group of points in the space, arranged in the space, which indicate the position of atoms, ions or molecules of the crystal. The crystal lattice is the actual particles occupying the lattice points known as crystal lattice. In this crystal lattice, there is a repeated smallest portion. That really repeated smallest portion is called unit cell. So, in unit cell, where are the lattice points? In unit cell, the lattice points are called center of base, body center or center of body, edge center, center of edge, center of edge. So these are the different locating points, different points which locate the position of the particles in the crystal. That is about unit cell, right? But the particles at corner, except body center, the particles at remaining lattice points are not completely belonging to the unit cell. Why? Because there are many rooms in a portion or floor. Therefore, some walls are common to some rooms. So like that, a wall is common if two rooms are constructed. Like that here, corner of the particle at the corner, particle at the face center, particle at the edge center, not belonging completely to that unit cell. A part is to this unit cell and the remaining part to the neighboring unit cells. That is very, very important, neighboring unit cells. Therefore, this is a very difficult concept. Of course, it is not right word to say you beginning difficult. If you are nicely following my explanation, you can easily catch the information. So observation listening is very, very important, my dear. Imagination is also playing a role at the same time. And now we are going to talk about a number of atoms in a unit cell. So the present topic is number of atoms in a unit cell. Number of particles or atoms in a unit cell. This is the point today we are going to discuss in this present video. Yes. Let us take the information. I would like to draw a cube like this. Your comfort is very, very important. Yes. First of all, I would like to give you the information regarding right. This is a cube you are watching, and this is a face. What I am marking is a face. Yes, your room where you are sit, observe the room, that is nothing but a cube, and the wall in front of you, a face, back side to you, a face, right hand side to a face, left hand side to a face. Top roof is also a face, bottom the floor is also a face. 6 faces are there. So these are all faces what I am marking, not all faces. Yes, this is a portion for imagination purpose, understanding purpose, and drawing the faces. Okay, now the particle at middle of the cube, that is body centered, center of body center, the particle is not belonging to neighboring unit cells. So if you extend this one like this, you will get a neighboring yes, this is a neighboring unit cell. Therefore, this particle is not belonging to any one of the neighboring unit cells. Just like your room is associated with some other rooms in your house. So, like that, this particle is not shared by any other unit cells. Not shared. It cannot be shared by any other unit cells. Very, very important. Now, I would like to make this particle, yes, your room is divided into 2 rooms by placing a plank. So I am placing a plank like this. Yes, what is the result, dear students? Yes, the particle, this is the particle, a plank is placing, and what is created? A face is created between. Yes, the room is divided into 2 rooms. So therefore, the room is divided into 2 rooms, and the particle is now divided into half part to this room and half part of this room. And this plank is behaving as, the plank behaves as a face. So therefore, face is, the particle at face is not completely belonging to this room or to that room. Half to this room, half to that room. So therefore, the face center can be shared by, yes, each face is shared by 2 unit cells. A particle at face center shared by half this unit cell, half to that unit cell. That is very important. This is one, this is another one. Is it clear? Yes. Take this is vertical division. The particle vertical division, room divided into 2 rooms. Next, horizontal division. Horizontal division, yes. Vertical division 2 rooms, and horizontal is 4 rooms. 2 rooms becomes 4 rooms. Therefore, the particle is an edge. Now the particle is on at how many edges? This is one vertical and this is horizontal. Vertical, horizontal. Yes, this is the edge. So at the edge, how many unit cells are there? Unit cell 1, unit cell 2, unit cell 3, unit cell 4. So edges are shared by, center of edge is shared by 4 unit cells. Each edge is shared by 4 unit cells. You just keep 2 books like this, 2 books, and a 3rd book on this one, and 4th book on this one. So this edge, here the edge is shared between 2. This is 2-dimensional, 3-dimensional. Above one, above this one, another one, 4. So therefore, the edge is shared by, the particle at the face center is shared by 4 unit cells, and each head has how much portion? 1/4 portion is resultant. Now, the particle is now divided into, yes, one vertical division, next one horizontal division, now another vertical division. So this is one vertical, second vertical, 4, correct? Apple is taken, vertical division 2, another vertical division 4, horizontal division 8. So this big room now divided into 8 small rooms. This big room is divided into 8 small rooms. How, dear students? One vertical, another vertical, and one horizontal. So 8 rooms are resulted. You just play with one apple and cut into 3 cuts. One is vertical, one second vertical like this, third horizontal like this. 8 pieces. So that middle is known as corner of a cube. So therefore the corner is shaped by 8 unit cells. The big room is now, the big room, this is body centered, now becomes a corner of 8 small cubes. This bigger apple, assumed as apple, this bigger apple-like particle at the body centered beginning, now divided into three divisions. One is one vertical, second vertical, third horizontal. Then this particle becomes a corner of 8 small cubes. And if you remove 8 small cubes, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, they are coming, and that is 1/8 is. So this is the main idea about the portion of, how much portion of the particle belonging to the present unit cell. A corner, if a particle at the corner only 1/8 is present belonging to this unit cell, remaining 7/8 belonging to other neighboring unit cells. Next, center of the face, half is belonging to this unit cell and half is belonging to neighboring unit cell. Next, body center, that is in the middle of the room, that is not shared by any other unit cells. This is very, very important. Whereas edge, take one book, another book, both are kept. The edge is in contact with the 2 books, and one book over this one, another book over this one. You will get 4 books with one edge. So the particle at an edge is shared by 4 neighboring unit cells. 1/4 of this unit cell, remaining 3/4 of other 3 neighboring unit cells. I hope you followed this small portion. If it is clear, we shall move to the main calculation. Let us take the contribution. Once again, the main story is to be recalled. Contribution of particles in a unit cell. Yes. The first one is corner. Each corner is shared by 8 unit cells. Corner into 1/8. Next, face center. Face center is shared by 2 unit cells. A particle at face center, half of this 2 unit cell, half to the neighboring unit cell. 3. Edge center. Edge center is shared by 4 unit cells. Body center as body center into 1, that is not shared by any other cells. Now for 2 marks, what is the question? If you understand this one, very easy to calculate. Yes, the question is calculate the number of atoms in FCC unit cell. This is 2 marks of board examination calculation. Answer is 8 corners. Each corner is with 1/8 part. So 1/8 part into 8 corners. 8 corners into 1/8 is equal to only 1 particle. If the particles are occupying all the corners of a cube, how much portion is belonging to this unit cell? 1. While particles are 8, after sharing with the neighboring unit cells, at 8 corners, now only one particle is resulted. Next, what is FCC face center? 6 face centers. The particles at 6 face centers shared by 2 unit cells. Each corner only half. 6 halves we have. 6 halves 3. Now, total particles. Total number of particles. Your answer is 4. This total number of particles is known as Z. Yes, this is given by letter Z. Generally useful in which is denoted by Z. Of course, Z, the letter used previously by you in first year as atomic number, but here in this chapter, Z indicates the number of particles per unit cell in a particular system is important. So this is after sharing, the property of the parents. If 2 children are there, shared between 2 children. If one child is there like body centered, cannot be shared. 4 children are there, shared. 8 children are there, shared. Like that, the property of the parents and grandparents possible to share at the time of dividing the family. Like that, this is also corner is shared by, each corner is shared by 8 unit cells. So the portion of this unit cell is only 1/8. Face center, half is only to this unit cell, edge 1/4 of this unit cell. So this is important. I think you little bit followed, not that much. Why? Because it is a little bit dry. The concept is a little bit dry. That is. Okay. Next one is calculation. Calculate the number of particles per atoms in BCC we have to take. Right, in BCC, what is observed here, students? In BCC, the particles are at corners. So 8 corners shared by 8 neighboring unit cells. So the portion is 1/8 of this unit cell. 8 into 1/8, that is 1 particle, and 1 body center. What is the specialty of body center? Cannot be shared. So that is 1. Total number of particles 1 plus 1, that is equal to 2. Now take the last one, simple cube. In simple cube, what is the lattice point? Only corners. So 8 corners, that is a primitive unit cell, simple cubic unit cell, 8 corners shared among 8 unit cells. So the contribution is 1/8 of each corner, 1/8, 1/8, 1/8, 1/8. And 4 1/8, that is 8 1/8 becomes 1. So the answer is total number of atoms or particles given by Z is equal to 1. This is calculation 1 mark, and final answer 1 mark in the final board examination. Get ready about this one. Yes, after this we shall move to some objective questions based on this. Formula of a compound is to be taken. Before that, I shall give you the structure of rock salt NaCl. I hope you followed this one. That is sufficient. Yes, once again, contribution of particles unit cell corner. How many corners? By 8 plus face center by 2. Next, edge center. Edge center shared by 4 units. Body center cannot be shared. Body center by 1. If you remember this one, easy to calculate the following next portion. Now, rock salt FCC structure. Very, very important, this one. And what we are going to take under this one. Rock salt FCC, rock salt is NaCl. NaCl in the form of Na plus and Cl minus. So larger Cl minus ions larger Cl minus ions are occupying corners of the cube. At corners of the cube as well as center of the face. Center of the face. Right. Where are Cl minus ions occupied? Cl minus ions are occupying at two lattice points. One is corner and second one is face center. And Cl minus ions or Na plus ions being smaller size of the ions, smaller size of the ends. If the particles are arranged, then close packing like this. This is the arrangement. And even though they are closely packed in solid state, there are some gaps. These gaps are known as interstitial spaces or voids. Here two types of voids are resulted. They are at, okay, after knowing the voids, I will give you, not at this stage. Why? Because some concept will be explained. After the concepts, we shall move to this one. Now, formula of a compound. Formula of a compound. First problem we have to take and then solve it. Yes, observe some things, dear students. In a crystal, atoms of element A occupy at corners of a cube, while atoms of element B occupy at face center of the cube. What is the formula of the compound? Yes, this above information helps you a lot. Where are A? Answer. A at corners. Therefore, A at corners, that is 8 into 1 by 8. All corners are occupied. So, number of A atoms are 1 in number. B at face center. Face centers are 6 into 1 by 2. 3. Hence the formula is A1, B3 or simply AB3. Answer is over. Yes, observe another problem, dear student. That is, in a crystal, atoms of element A occupy at the corners of a cube, while atoms of element B occupy body center. This is body center and A is at corner. A is at corner and B is at body center. See, A is at corner, answer. A is at corner, that is 8 into 1 by 8, answer is 1. B at body center, as body center cannot be shaped, that is 1 into 1, 1. Hence the formula of the compound, A1, B1, nothing but AB. Yes, observe the question, my dear students. In a compound, atoms of element X occupy corners of a cube. Element X, corners of a cube, and atoms of element Y at all face centers. Element Y at all face centers. Right. So, solution. X at corners and Y at face centers. Okay. Then this is very important. Along one axis, all the atoms are removed. Yes. Observe the diagram. For understanding purpose, diagram is not necessary to draw always. Yes. This is one axis. So therefore, three axes, X, Y, Z. This is X, this is Y, this is Z. See here, this is X, this is Y, and what is here going on is Z. Along one axis means here these four particles are removed, and this face centered, that face centered also removed. Two faces removed and four corners removed. Correct? No. Yes, that's only. All the face centers, if all the atoms along one axis remove, all the atoms yes, this is one axis. Wait, all the I would like to change the problem. All the atoms one axis, all the atoms at face center along one axis removed. Okay, two faces are there. Therefore, out of 6, 2 are removed. 8 corners cannot be removed. Therefore, the formula is x 8 into 1 by 8, that is 1 in number, y 6 minus 2, 4 into 1 by 2, 2. Therefore, the formula of the compound is xy2, x1, y2. I hope you followed this one without confusion. Once again, see the formula problem. The problem is the compound, in a compound atoms of X occupy corners of a cube and element Y at all face centers. If all the atoms at face center along one axis removed, then the formula of the compound. So along one axis, how many atoms are there? 6 atoms, about 6 faces. Along 3 axes, each axis has 2 faces. So therefore, 2 removed along one axis. Therefore, 6 minus 2, they become 4. 4 into each face is shared by 2 unit cells. So 4 into half 2, x1, y2 is the formula of the compound.